What's up YouTube, and welcome back to my channel. Today we're going to be doing another study session that's tailor-made around fractions. How to solve fraction-based questions. This is going to help you greatly improve upon your Asvab score, not just your Asvab, but your SAT, your ACT, and even your GED studies. So if you don't feel confident solving a question like this, then you're in the right place. So get your pen, get your paper, because we're going to be in the trenches in today's video. So stay tuned because it's coming up. First and foremost, I just want to say welcome back to another study session. If you're new here and you're seeing me for the first time, most likely you have an Asvab test coming up, or you just recently failed an Asvab and you made a vow to yourself that you need to pass your next test in order to enlist in the military. I just want to let you know, congratulations. The fact that you're listening to my voice right now means that you're willing to invest in yourself. So welcome. Go ahead and hit that subscribe button so I can say welcome to the family. In today's video, we're going to be going over the basics of fractions. How to solve fractions. What are fractions? How do we add? How do we subtract fractions? How do we multiply, divide, or even simplify fractions? So before we begin solving any of these fraction questions, if you haven't already, go over to this video. This is the fraction pop quiz that I just recently posted. Go over to this video. It'll have all of the questions that are in today's video. However, you can go through on your own time at your own pace by solving each question. When you finish the pop quiz, go ahead and take your answer sheet and bring it over to today's video in order to maximize your study quality. By the end of today's video, you'll be able to solve questions like this, even this. So go ahead and take a second to grab your pencil, grab your paper. I recommend even having a calculator that's close by because we want to maximize what we're getting out of these study sessions. So first and foremost, what are fractions? A fraction is basically a numeric value that is not a whole number. So what is a whole number? Whole numbers are 0, 1, 2, 3, 4, so on and so forth. A fraction is a number that's actually in between 0 and 1. So 1 over 2, or aka 1/2, is right in the middle of whole numbers 0 and 1. A fraction is basically a part or a portion of something. The bottom number represents the total amount that we have altogether, whereas the top number represents how much we are using or how much that is currently available at the time. So now that we know what a fraction is, let's talk about how to add or subtract fractions. All right, ladies and gentlemen, as always, let's go ahead and dive into doing some mental warm-ups. We're just going to take a minute or two to go over some of these multiplication questions. While I give you a chance to go get your pencil, your paper, what is 12 times 2? 12 times 2. I got 24. 10 times 10. What y'all got? 20? 110? 10 times 10. 100. 4 times 4? 16. Y'all already know the drill. Go ahead and comment in the comment section what y'all are getting for answers. 1 times 1. We know that 1 times anything is itself. So we got 1. 7 times 7. Y'all know your 7 times tables. What is 7 times 7? Go ahead and comment in the comment section down below. 7 times 7. I got 49. 4 times 12. We should be getting a lot faster. Now that we've been doing this for so long, we should be getting a lot faster. 48. 8 times 10. We know that anything times 10, we just add a 0 to the end. 80. 6 times 3. What y'all got? I got 18. 5 times 4. I got 20. 1 times 1. We already did this. 1. 8 times 0. We did that already, I think. 80. 2 times 3. 6. 8 times 6. What y'all got? 8 times 6. Is it 44? Is it 45? Is it 46? Or is it 48? 8 times 6. What do y'all got? What do y'all got? 48. We know that anything times 1 is itself. So 2 times 1, that's 2. 7 times 12. This is a good one because I don't think a lot of y'all know your 7 times tables or your 12 times tables. 7 times 12. I got 84. 6 times 5. 6 times 5. 30. The reason that we do this, somebody asked in the comment section like why we do this, and another person asked for the link that I'm using for this multiplication flashcard. So I'm gonna go ahead and link the link in the comment section down below. I'm sorry, in the description down below, so that way y'all could do it on your own time as well. 12 times 8. This is a good one. 12 times 8. Another 12 times tables. 96. All right, sweet deal. So I think that this is becoming too easy. All right, so let's go ahead and do it like this. 60 more seconds of doing it like this before we dive into the questions. 10 times 5. I got 50. 6 times 4. 6 times 4. Is it 24? Y'all got faith in me? 24? Let's see. Boom, 24. 9 times 5. What is 9 times 5? Is it 40? Is it 50? Is it 60? 45. 3 times 9. 27. 4 times 4. 16. This is going to save you a lot of time on your Asvab. If you know your multiplication times tables or even your division times table, it's going to save you a lot of time on the Asvab. For example, instead of doing 9 times 5 and adding 9 5 times, 9 plus 9 plus 9 plus 9 plus 9, it's going to help you a long way if you can see that 9 times 5 is 45, right? You just saved yourself probably 3 minutes right there. 4 times 10, 40. Again, 9 times 5, we just did this, 45. 2 times 1, that's 2. 3 times 6, what is 3 times 6, y'all? I think that's another thing that trips people up. They're 3 times tables for whatever reason. 3 times 6, 18. All right, 20 more seconds, and then let's wrap this up. 12 times 5. 12 times 5. Here go your 12 times tables again. 12 times 5. 60. 3 times 7. 21. All right, 10 seconds of speed round. 9 times 1, we got 9. 7 times 4, I got 28. 8 times 9, I got 72. 8 times 1, I got 8. 7 times 12, oh, this is a good one. I got 84. What y'all got? Boom. 6 times 3, I got 18. 2 times 1, 2. 3 times 1, 3. 7 times 9, this is a good one. We're going to end on this one. Comment in the comment section down below what 7 times 9 is, y'all. 7 times 9. Comment in the comment section down below. I got 63. So good job, ladies and gentlemen. If you participated in today's mental warm-ups, great job. But without further ado, let's go into the main topic, adding and subtracting fractions. How do we add and subtract fractions? All right. This is the first question. 1 over 2 plus 1 over 4. 1/2 plus 1/4. All right. All right, so we can see step 1 is that we need to find a common denominator. So let's go ahead and write this out. 1 over 2 plus 1 over 4. So when I say common denominator, start thinking the bottom number. Denominator. Whenever you hear denominator, we're talking about the bottom number. Okay? So what number goes into both 2 and 4? If we need a common denominator, what number goes into both 2 and 4? Well, it would make sense if this 1 over 2, we can change this 2 to 4, right? 2 goes into both of these numbers, right? Or both of these numbers go into 4 because we need a common denominator. So in order to make this 4, we have to multiply this denominator by 2. All right. 2 times 2, we know, will give us 4. And then this fraction over here will still stay the same because 4 is already the denominator. So whatever we did to the denominator on this side, we also have to do to the numerator or the top number on this side as well. So we multiplied by 2. Is that correct? So 2 times 1, we know, is 2. So this will be our new equation, 2 over 4 plus 1 over 4. Because we have a common denominator, we can now add the numerator. So 2 plus 1, we know is 3. And the denominator stays the same. All right, so we just went through our 4 steps. We found our common denominator. What we did to the denominator, we did to the numerator, right? Which was multiplied by 2. We added our fraction as it asked us to do. And now it's asking to simplify the fraction. Can we simplify 3 over 4? The answer is no, we cannot simplify 3 over 4. It's already simplified, right? So there's no need for us to simplify the fraction. 3 over 4. We go to our answer key and we can see that A would be the correct answer. 3 over 4. If this is looking like a foreign language to you right now, it's okay. We're going to be going through multiple questions of these, so don't be discouraged. Go ahead and screenshot this if you need a screenshot, because I'm about to delete everything off the screen in about 2 seconds. All right, 3 over 4 is the correct answer. All right, let's go to the next question. 5 over 8 plus 1 over 4. This is a good one. 5 over 8 plus 1 over 4. So whenever we're adding or subtracting fractions, we need to be thinking what? Common denominator. Right? Common denominator. AKA, what number goes into both 8 and 4? The answer would be 8. Am I correct? We can change this 4 into an 8 if we so choose, right? So we're going to rewrite this fraction. Let me make sure I clear this. We're going to rewrite this fraction. 5 over 8 will stay the same. So we have 5 over 8, right? And then this 1 over 4, if we multiply this 4 by 2, that would give us 8 as a denominator on this side. 2 times 4 we know is 8. But what we do to the bottom, aka the denominator, we also have to do to the top. So we have to multiply the top by 2 as well. 2 times 1 we know is 2. And now we have our new equation. 5 plus 8 plus 2 over 8. We can add 5 plus 2 gives us 7. And we know that the 8 stays the same. The denominator stays the same. So we go down. Can we simplify this fraction? The answer is no, we cannot. 7 over 8 is already simplified. We go to our answer key and we can see that B would be the correct answer. One of these days, I'll probably do a live stream with these same set of questions to give you guys an opportunity to answer any of the, not to answer, but to ask any questions that you have. But 7 8 would be the correct answer. Go ahead and screenshot if you need. We're going to be diving into another question. All right. 3 over 8 plus 1 over 2. All right, we are still adding fractions. And whenever we're adding fractions, we need what? A common denominator. So, common denominator, we're thinking, all right, what can we do with both of these numbers? What number can we make as the common denominator between both 8 and 2? Does 2 go into 8? Yes, it does. right? So we know that 8 would be our common denominator. So we have 3 over 8 plus, and then on this side, how do we make this 2, or this denominator over here, 8? Isn't it true that we would have to multiply by 4? 4 times 2 is 8. And then whatever we did to the denominator, we have to do to the numerator as well. So we have to multiply the top by 4 also. 4 times 1, we know is 4. And now we can add going across. 3 plus 4, we know is 7. And the denominator of 8 stays the same. 7 over 8. Don't forget now, it's going to ask, can we simplify the fraction? That is the final step. So far, we haven't simplified any of our fractions. Can we simplify 7 over 8? Is there a number that goes into both 7 and 8? The answer is no, right? This is already simplified. 7 over 8. So we go to our answer key. We see that D would be the correct answer. 7 over 8. All right. I think we're beginning to pick up steam, right? I think that we're tracking. We're beginning to all be on the same page. So what I'm going to do is I'm going to take this little cheat sheet that's on the top. We're about to get rid of it, and we're about to solve this on our own. Here we go. 9 over 12 minus 1 over 3. All right. So we know that the steps remain the same. We need a what? A common denominator. What is the denominator that we can use for both 12 and 3? Can 3 go into 12? Absolutamente. Right? So we have to do what? This denominator of 12 will stay the same, meaning that this 9 up top will also stay the same. We know that we are subtracting. And then what? How do we make this 3 a 12? What do we have to multiply by? 3 times what is 12? Okay? 4. I don't know what just happened there with that pen, y'all. Bear with me. Right? We multiply by 4. So 3 times 4, we know is 12. Whatever we did to the bottom, we also have to do to the top. 1 times 4, we have 4. 9 minus, don't forget to note that we're not adding, we're subtracting. 9 minus 4 is 5. And we'll have a denominator of 12. The 12 stays the same. 5 over 12. Can we simplify? Don't forget to simplify. Can we simplify? So far, still, the answer is no. 5 over 12 would be the correct answer because we can't simplify any further. 5 over 12. All right, not bad for not using our cheat sheet. So let's go ahead and dive into the next question. This is a good one. Two over 3 minus 9 over 15. 2 over 3 minus 9 over 15. So, common denominator, what number goes into both 3 and 15? What is the denominator that we can use for both 3 and 15? 15. Right? So then this 9 over 15 stays the same. We're going to be subtracting. 15 is going to be our common denominator, right? Because 3 times 5 or 5 times 3 will give us 15 as a denominator. Whatever we did to the bottom, we also have to do to the top, right? 5 times 2 is 10. So we have 10 over 15 minus 9 over 15. Right, we're going to subtract the numerators. 10 minus 9 will give us 1. and 15 will be our denominator. 1/15. We can't simplify this any more than it already is, so 1/15 would be the correct answer. B would be the correct answer, 1/15. Right? We use 15 as a common denominator. We multiplied by 5. We also did the same to the top. 5 times 2 is 10, and then we subtracted coming across. 10 minus 9 gave us 1. 1/15 is the correct answer. So far, so good. If you have a question, go ahead and comment in the comment section down below what your question is. And then if you know the answer to the question that you read in the comment section, go ahead and comment and help your battle buddies out. All right, go ahead and help your battle buddies out. If you see somebody struggling and you know how to solve it, go ahead and comment on their comment section, because we're all in this together as a community. All right, let's go ahead and try this other question. 3/8 minus 1/3. So this is a good one because we need a common denominator. At this point, we know this, right? However, 3 doesn't go into 8 directly. So how then do we find a common denominator? What does 8 go into that 3 also goes into? All right. So a little trick that I would give to you guys, right, is I would take the bigger number between 8 and 3, which would be 8. And then I begin to do 8 times tables in my head. 8 times 2 I know is 16. Okay, let me just write it right here. 8 times 2 is 16. Does 3 go into 16? No, it doesn't, right? So I know 16 can't be the common denominator, right? 8 times 3, 24. This is why we do the mental warm-ups in the beginning. Okay, does 3 go into 24? Can we multiply a number by 3 that also goes into 24? Yes, we can, right? And the number would be 6. Is that right, y'all? 6? 6 times 3 is 24? No, right? That's not the correct answer. Okay, so what would be the correct answer? 8. 3 times 8 is 24. Okay, so whatever we did to the bottom, we also have to do to the top. So we have to multiply this numerator also by 8 to give us 24. So we know that 24 would be the common denominator. Okay, so that's a little thing that I do. I normally start with the bigger number, which is 8, and then I start going the 8 times tables. If you start with the smaller number being 3 and you do the 3 times tables, 1, it's a lot more work, and 2, you will be going for a very long time. You know, 3 times 2, okay, that's 6. 3 times 3, that's 9. Does 8 go into 9? 3 times 4, that's 12, and so on and so forth. It'll be a lot more painful. Okay, so start with the bigger number and then just do that times tables. So 8 times 2, we know that is 16. 3 doesn't go into 16. 8 times 3, that's 24. We know that 3 does go into 24. Another trick that I would tell you is the quickest way to find a common denominator would just be to multiply this denominator by that denominator right here. Okay, it works every time. If you're just looking for the quickest way to find the common denominator, multiply these two numbers together, right? So on this side we have 8 times 3, meaning we have to multiply 3 here, and on this side we have 3 times 8, so we have to multiply 8 on this side, and this is going to give you 24, right? 3 times 8 is 24. 3 times 3 is 9. We're subtracting, and then on this side we have 1 times 8 is 8, and we know that 3 times 8 is 24. So we have our common denominator, and now we can subtract coming across, right? 9 minus 8 is 1, and our common denominator of 24 stays the same. 1/24. We can't simplify any more than it already is, so we have our answer B being 1/24. All right, so different ways that you can go about finding the common denominator. Very important. Very, 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 very important. Either multiply the denominators together or start with the larger number and then just start going the times tables, right? 8 times 2, 8 times 3, 8 times 4, up until you recognize a number that 3 also goes into. Okay? Let me go ahead and clear this off the screen so that way we can try another one. Okay. So very similar. Very, very similar. 3 over 8 plus 1 over 3. So instead of subtracting, we're actually adding. Okay. So we know that the common denominator between both 8 and 3, because we just did it, right? We multiplied by each other. It was 24. Instead of subtracting this time, we're actually adding. So we're going to put our addition sign in there, and I'll still write it out so that way nobody's confused. 3 times 8, we're going to multiply by 3 on this side to give us 24. Whatever we did to the bottom, we have to do to the top. And on this side, 3 times 8 gives us 24. So whatever we do to the bottom, we do to the top. We're going to get the same numbers. 3 times 3 is 9 plus, and then what we have over here, 1 times 8 is 8. 9 plus 8 is what? 17 over 24. Is there a number that goes into both 17 and 24? There is not, right? I believe 17 is a prime number, meaning nothing goes into that bad boy except 1 in itself, right? So A would be the correct answer. 17 over 24. I think by now we should be getting a hang of adding and subtracting fractions, right? So let's go ahead and burn through a couple more real quick, and then we'll pack it up for the day for adding and subtracting fractions. Okay. 7 over 16 plus 1/3. What number goes into both 3 and 16? Looking at it for face value, it might be difficult to figure out, right? So I would recommend in a case like this, just multiplying, like I said, both of these numbers together to give you the quickest common denominator between them. Okay. So over here, I will write 16 times 3 if we don't know it in our heads. 3 times 6 is 18. 3 times 1 is 3. And then we're going to add that 1 up there, giving us 4 for an answer of 48. So 48 would be our common denominator. What did we do? We multiplied this 16 by 3. So we have to multiply that 7 by 3 as well. And on this side, we multiplied this 3 by 16. So we also have to multiply the numerator by 16. All right. So our common denominator is 48. We are adding. All right. 3 times 7 is 21. And 1 times 16 is 16. 21 plus 16. I'll go ahead and write it over on this side. 21 plus 16. 1 plus 6 is 7. 2 plus 1 is 3. We have 37 over 48. 37 over 48. Can we simplify this fraction? Is there any number that goes into both 37 and 48? The answer would be no. 37 over 48 would be your final answer. D would be your final answer. All right. All right, next question. 5 over 6 plus 3 over 4. What number goes into both 6 and 4? What number can we use as our denominator? Right? It's true that 6 goes into 12. Yep, that is true. And it is also true that 4 goes into 12. So we can use 12. Why did I use 12? Why did I just jump straight into 12? Because I took the 6 being the bigger number between the two, and then I just did 6 times 1 obviously is 6, and then I went down the list. 6 times 2 is 12. I looked over, 4 goes into 12, so I knew that's as far as I needed to go, right? So I multiplied this side by 2 to get a 12 as a common denominator, so we also have to multiply the top by 2. And then on this side, 4 times 3 gives us 12, so I have to multiply the top by 3 as well. 2 times 5 is 10. 3 times 3 is 9. And then I'll add coming across. 10 plus 9 is 19. And then our denominator of 12 stays the same. Whoa, look at this number right here. We have 19 over 12. This is the first time so far that we have seen a bigger number on top than on the bottom. This is called an improper fraction. Okay? Whenever your fraction is heavier on the top than it is on the bottom, it's called an improper fraction. So what we need to do is we need to make this fraction make sense. Okay? Just the title of it alone, called an improper fraction, says a lot, right? So we need to make it make sense, all right? And how we do that is we take this denominator, 12 being the denominator. How many times does 12 fit into 19? Isn't it true that 12 can only fit into 19 a total of 1 time? Because if we do 12 times 2, we'll have 24, and that's bigger than 19, right? So 12 fits into 19 a total of 1 time. Okay. With how much remainder is left over, right? So if it's in 1, we can get 1 full 12 in there. But how much remainder do we have? So from 12 to 19, what is the difference between 12 and 19, right? 13, 14, 15, 16, 17, 18, 19. Isn't it 7? 19 minus 12 is 7 as a remainder. That is correct. And then the denominator of 12 stays the same. So this is called a mixed number. 1 and 7/12 is the same value as 19 over 12. However, it's not an improper fraction. Okay, so how we did that, just a little recap. 12 fits into 19 a total of 1 full time, right? With 7 remainders, and the denominator of 12 stays the same. 1 and 7/12. We go to our answer key and we can see that D would be the correct answer. 1 and 7/12. Okay, we changed our improper fraction into a mixed number, meaning it has a whole number, but it's also a fraction. 1 and 7/12. Okay. This will be a good key to stick in your back pocket, because I'm pretty sure when dealing with fractions, at some point you're going to see both improper fraction and mixed numbers, okay? So just keep that in your back pocket. That one was for free. All right, let's go ahead and move on to the next question. Boom, here's a good one. This is what they like to call a complex question. 1 over 2 plus 3 over 4 minus 1 over 3. Wow. All right. Don't get intimidated by seeing this. What do we need? We still need a common denominator. In order to do any adding or subtracting of any type of fractions, you'll always need common denominator. All right. So let's see what number goes into these denominators that we have. You can either break this down and do 1 over 2 plus 3 over 4, find the answer to that, and then subtract it by 1 over 3 as a separate question, or we can just try to do everything at the same time. I'm feeling a little froggy right now, so let's just do everything at the same time. All right, what number goes into 2, 4, and 3 at the same time. So we're going to take our method that I said, right? We're going to take the largest number. Does 2 go into 4? Yes, it does, right? However, does 3 go into 4? No, it doesn't. So if we needed to find a common denominator between all of these, we know that 4 wouldn't be it. All right, so let's multiply 4 times 2, right? Let's multiply this 4 right here times 2, giving us 8. Does 2 go into 8? Yes, it does. But does 3 go into 8? No, it does not. So we know that 8 wouldn't be the common denominator to use, okay? We're going to multiply it again. Let's do 4 times 3. 4 times 3 is 12. Does 2 go into 12? Yes, it does. But does 3 go into 12? Yes, it does also, right? So we know that our common denominator can be 12. All of these numbers go into 12. 2 goes into 12, 4 goes into 12, and 3 goes into 12. All right, that's what I mean by different methods to find the common denominator. If we're doing all of these at the same time, which it's possible, we just needed to find a common denominator of 12. So what do we do in order to make this 212? Isn't it true that 6 times 2 gives us 12? Yes. So whatever we did to the bottom, we have to do to the top. Multiply that by 6. What did we do to this 4 in order to get it to 12? We multiply by 3. 3 times 4 gives us 12, so we also have to multiply our numerator by 3. What did we do to this 3 on this side to give us 12? We multiplied by 4. So whatever we did to the denominator, we also have to do to the numerator. Multiply by 4. Right? 6 times 1 gives us 6. 3 times 3 gives us 9. 1 times 4 gives us 4. And now that we have a common denominator between all three of these, let's go ahead and solve this. 6 plus 9 equals 15. Boom. 15 minus 4 equals 11. And our denominator of 12 stays the same. 11 over 12. We go to our answer key. Well, first we know that we can't simplify this 11 over 12. We go to our answer key, and C would be the correct answer. Boom. What a complex question, right? But not too bad. The steps still remain the same. Find a common denominator, and then whatever we did to the bottom, do to the top, and then just follow the functions as necessary. We added 6 plus 9, giving us 15. We subtracted 15 from 4, giving us 11 over 12. And we know that we cannot simplify, so that was our final answer, 11 over 12. All right, one last complex question before we wrap it up. We're going out on a good note if we can solve this. 1 over 4 minus 3 over 16 plus 3 over 4. All right. Looking at this, we can see that 16 would be the common denominator because 4 goes into 16, and to our luck, we have 4s on both sides. So we're going to use 16 as a common denominator. We're going to use 16 in the middle, and we're going to use 16 on the right hand side. The function on the right is a plus, the function on the left is a minus. What do we do? 4, we have to multiply this 4 by 4 in order to give us 16. What we do to the bottom, we also have to do to the top. The middle number stays the same because it already has a denominator of 16. And then the same thing on this side. We have to multiply this 4 by 4. So we have to multiply this 3 up top by 4. Starting with the left, 4 times 1 is 4. Going to the right, 3 times 4 is 12. And let's follow our functions. 4 minus 3 equals 1. And then 1 plus 12 equals 13. 13 over 16. Final answer. Can't simplify. 13 over 16. We go to our answer key. D would be the correct answer. So it doesn't matter if we seen improper fractions, mixed numbers, complex equations, we can still solve them if we follow the steps. Find your common denominator. Whatever you do to the denominator, you also have to do to the numerator up top. Follow the functions, either adding or subtracting, and then simplifying the answer that you have at the end. That is how you add and subtract fractions. Now that we know how to add and subtract fractions, let's dive into how do we multiply fractions. So how do we multiply fractions? There are 3 simple and easy steps to multiplying fractions, and I actually believe that multiplying fractions is easier than adding and subtracting fractions. The first step to multiplying fractions is, can you cross-simplify your fraction? Next, we are going to multiply both numerators of the fraction and denominators of the fraction in order to write our answer. And then, like always, the third and final step is, can we simplify our fraction anymore? If you didn't cross-simplify in the beginning, most likely you'll have to simplify at the end. However, if you did cross-simplify in the beginning, go ahead and just double check that your answer doesn't need to be simplified at the end as well. All right, y'all. So next, let's talk about multiplying fractions. How do we multiply fractions? So actually, we have a new terminology called cross-simplifying. Cross-simplifying, right? Basically, cross-simplifying is very simple, all right? What we're going to do is we're going to take the numerator of this side and the denominator of that side, right? And we are going to see what number goes into both 6 and 9, right? I'm a big fan of cross-simplifying because it makes your life easier when trying to multiply these big numbers, okay? What number goes into both 6 and 9? The answer is 3. 3 goes into both 6 and 9. So 9 divided by 3 is 3. And 6 divided by 3 is 2. Right? So we just cross-simplified half of our fraction. Right? Now let's cross-simplify the other half of our fraction. So we're going to look at this 15 here, and we're going to look at this 5 over here. What number goes into both 5 and 15? The answer would be 5 itself. So 5 divided by 5 is 1. And 15 divided by 5 is 3. Why is this important or necessary? Again, it saves us a lot of work on the back side, okay? So let's go ahead and rewrite the fraction that we have. So we have 3 on top over 3 on bottom on that side times 1 on top and 2 on the bottom of this side. 3 over 3 times 1 over 2. Okay? 3 over 3 times 1 over 2. And now it's so much easier to multiply 3 times 1 versus 9 times 5. Or it's so much easier to multiply 3 times 2 versus multiplying 15 times 6, right? So this is why I'm a firm believer of cross-simplifying your fraction before we even get into multiplying the fraction. All right, if we didn't do this, then obviously we would have to multiply 15 times 6 and it becomes a big hassle. All right, so that being said, let's go ahead and dive into some of the questions that we have for today. All right, let's see the steps of multiplying fractions. So step 1, can you cross simplify? Let's see. Can we cross simplify 1 and 4? No, that's already in the simplest terms. And can we cross simplify 2 and 3? No, that's already in the simplest terms as well. Okay, so what we do actually Multiplying fractions, again, I feel like it's easier than adding and subtracting fractions because we don't need a common denominator. We can simply just do our math straight across. So we have 1 over 2, and then we have 3 over 4. All right, 1 over 2, 3 over 4, right? So 1 times 3 is 3, 2 times 4 is 8. Can we simplify? No, we cannot simplify, right? So 3 over 8 would be the final answer. B would be your final answer. So much easier than adding and subtracting. We can completely skip by the whole finding a common denominator. And listen, when we multiply, multiplying is OG, okay? Multiplying doesn't care about common denominator or anything like that, all right? So I personally love to multiply fractions versus adding and subtracting fractions, okay? We ask, can we cross simplify? Step 2, we just multiply going across, okay? And then step 3, simplify the fraction. 3 over 8, final answer. Boom. Let's go to the next question. 2 over 5, times 1 over 4. 2 over 5 multiplied by 1 over 4. Can we cross simplify? The answer actually is yes. We can't cross simplify. We can't cross simplify this 1 and 5, right? However, we can cross simplify on the other end this 2 and 4. Does that make sense? So we can cross simplify that 2 and 4. Okay? What number goes into both 2 and 4? Obviously, we know that it's 2 itself, right? 2 goes into 2 a total of 1 time. And then 2 goes into 4 a total of 2 times. All right, so we'll rewrite our fraction. 1 over 5 times 1 over 2. Okay, we multiply going across. 1 times 1 is 1. 5 times 2 is 10. We know that this is the simplest answer, 1 over 10. C would be the correct answer. So let's see what happens actually if we didn't cross simplify, right? If we didn't take 2 from both of these numbers, what would happen? All right. So let's go ahead and resolve this same question without cross simplifying. We would have 2 over 5 on this side times 1 over 4, just like that. If we didn't cross simplify, we just multiply coming across. 2 times 1 is 2. And then we'll have 5 times 4 is 20. Okay. On the Asvab and other questions that you take, you will actually have an answer in the answer key, right? Let's say E was another option. And what they would put is 2 over 20. A lot of people not paying attention will be like, okay, yeah, we just multiplied. E would be the correct answer, when in fact, it would not be the correct answer, all right? Because 2 over 20 is not in the simplest form, all right? This can reduce. 2 actually goes into 20, right? So we know that 2 goes into 2 a total of 1 time, and we know that 2 goes into 20, or aka 20 divided by 2, total of 10 times, right? So we notice that if we did not cross simplify, which is not too much of a big deal in this question because the numbers were kind of small, right? If we didn't cross simplify in the beginning, we just have to make sure that we simplify at the end, all right? C would be the correct answer. Again, I'm a firm believer in cross simplifying, especially when the numbers are like 16 times this and 22 times 19 and things like that. If we had cross simplified in the beginning, it would make our work a lot easier. Okay, so C is the correct answer. Let's go ahead and jump into the next question. 5 times 16 times 4 over 5. Right, I like to rewrite it. 5 times 16 times 4 over 5. Here's a good scenario to cross simplify. What number goes into both 5 and 5, right? Obviously the number 5 goes into both 5 and 5, right? So this would be 1. 5 goes into 5 one time, 5 goes into 5 a total of 1 time, right? So this kind of helps us a lot, to be honest with you. And then what number goes into both 4 and 16? 4 itself, right? 4 goes into 4 a total of 1 time. 4 goes into 16, right? A total of 4 times. 4 times 4 is 16, right? Total of 4 times. So if we go ahead and rewrite our fraction here, 1 up top, 4 on bottom, times 1 up top, 1 on bottom, and we multiply coming across, we'll realize that 1 times 1 is 1, 4 times 1 is 4. This is already simplified. It's already pretty for us. It is too easy. 1 over 4, aka C, would be the correct answer. Okay, you notice how we didn't even have to necessarily simplify at the end, and multiplying 1 times 1 and 4 times 1 is so easy. It's so easy. If we cross simplify, it's so easy. Excuse me. Let's go ahead and see what it would look like if we didn't cross simplify. So we have 5 over 16 times 4 over 5. If we didn't cross simplify and we just jump straight into this, 5 times 4, we know is 20. We can do that one pretty easily. And then we would have to do 16 times 5. If you are like that and you can do 16 times 5 in your head, then great job. But for a lot of people who struggle with these type of questions, this is where you would have wished you cross simplified, right? 16 times 5, maybe you might have to write that over here. 16 times 5. 5 times 6 is 30. Carry the 3 up top. 5 times 1 is 5 plus 3 is 8. Okay, 80 would be your answer. And then on top of that, this one again is kind of pretty for us, but on top of that, you would still have to simplify 20 over 80, you know? But what if it was 20 over 82 or 20 over 84? You know, it just becomes a lot more difficult, right? However, we know that 20 over 80, 20 goes into both of these numbers, right? So if we had to divide by 20, 20 goes into 20 one time, 20 goes into 80 4 times. 1/4, aka C, would still be the correct answer, right? I'm trying to preach this to you guys because cross simplifying was a tool that I came across coming up, and it helps me. It goes a long way, especially when dealing with fractions. Okay, cross simplify, cross simplify, cross simplify. All right, let's take the training wheels off actually, and let's dive into the next question. Okay, so let's cancel out our little cheat sheet up top, and let's see if we're able to do this on our own. 2 times 3. 2 over 3 times 9 over 16, right? So 2 over 3 multiplied by 9 over 16. Me, I don't even care if it looks small, right? I cross simplify everything. So what number goes into both 2 and 16? 2 itself goes into both 2 and 16, right? 2 goes into 2 a total of 1 time. 2 goes into 16 a total of 8 times. And then look at here, 3 and 9. What number goes into both 3 and 9? 3 itself. 3 goes into 3 a total of 1 time. 3 goes into 9 a total of 3 times. Let's go ahead and rewrite our fractions. 1 over 1 times 3 over 8. Man, this is so easy. It's kind of even insulting our intelligence. 1 times 3 is 3. 1 times 8 is 8. The answer is already simplified. 3/8 is the right answer. A is the right. And look how quick, look how smooth, look how easy that just worked out. First is multiplying 3 times 16, 2 times 9, and then trying to figure out how many times 18 over 48. You know, like this was just so pretty, so smooth, so effective. Okay, because we cross simplified, 3/8 being the right answer. Cool. We ready for the next one? All right. 3 over 4 multiplied by 7 over 12. 3 over 4 multiplied by 7 over 12. All right. Let's see what we got. Y'all already know what I'm going to say. Let's go ahead and see if anything can be cross simplified. Okay. Look at this. 3 and 12. 3 goes into 12, right? So 3 goes into 3 a total of 1 time. 3 goes into 12 a total of 4 times, right? 4 times 3 is 12. I think yes. And it looks like that's all that we can get away with right now. But hey, it counts for something. 1 over 4 would be the new fraction on that side. 7 over 4 would be the new fraction on this side. And then we multiply going across. 1 times, y'all don't even worry about this being an improper fraction, all right? This 7 over 4. We're just going to continue the equation and see what we got. 1 times 7 is 7. And then we have 4 times 4 is 16. This can't be simplified. 7/16. Boom. 7 over 16 being your final answer. So easy. Lord Jesus, thank you for allowing us to cross simplify. Right? Let's go ahead and jump. Let's jump to the last question for multiplication. Let's do the last question. Bam. You know me, we gotta go big or go home, right? So 1 plus 3 as the numerator over 4 times 5 as the denominator times 15 minus 12 plus 2 as the numerator over 12. Golly. So let's take this step by step. All right. Don't panic. Don't panic at all. Let's just do this step by step. We know that 1 plus 3 equals 4. We know that 4 times 5 equals 20. All right. This 12 will stay the same. And now let's just see on this side what we have. 15 minus 12 gives us 3. 3 plus 2 gives us 5. 5, and then the 12 stays the same on that side. Let's go ahead and rewrite our fraction. 4 over 20 times, what did I say? 5 over 12. Look at that. Boom. What's the first thing that I'm going to look to do, ladies and gentlemen? Cross simplify. You got that right. What number goes into both 4 and 12? That would be 4 itself. 4 goes into 4 a total of 1 time. 4 goes into 12 a total of 3 times. Right? 3 times 4 is 12. And then on this side, going diagonally, 5 does go into 20, so that works out very well. 5 goes into 20. 5 goes into 5, a total of 1 time. 5 goes into 20, a total of 4 times. Rewrite our fractions down here. We have 1 over 4 times 1 over 3. Look at this, man. What do they say? Easy peasy lemon squeezy. 1 times 1 is 1. 4 times 3 is 12. 1 over 12. Do we have that in the answer key? Yes, we do. B would be the correct answer. 1 over 12. Can you imagine having to multiply 20 by 12? You know what I mean? And then also having to simplify. It's too much, man. It's too much. It's way too much. Right? So cross simplify, cross simplify, cross simplify. If this doesn't make sense to you, I recommend going back in the video, replaying this multiplication section, so that way you can get a good understanding of what cross simplifying is and how effective that is, especially when dealing with these fraction questions, because it's going to help you a lot if you cross simplify. So let's dive into the last section of this video, which is how do we divide fractions? Well, that's kind of a trick question. You can't technically divide a fraction. However, what you would need to do is multiply by the reciprocal. So what does that mean? Because we can't divide fractions, we have to multiply fractions. So the first step is we're going to leave the first fraction the same. We are going to change our division sign into a multiplication sign, and then multiply by the reciprocal. Reciprocal means that we're just going to flip the second fraction. All right. So we are going to be moving on to dividing fractions. Okay, dividing fractions. So let's jump into dividing fractions. One, that's already kind of misleading. We know that we can't necessarily divide fractions. So what we have to do is follow the steps. Multiply by the reciprocal. So the first fraction remains the same. 3 over 16, right? So we keep the first fraction, 3 over 16. And then we have to change this division sign into a multiplication sign, right? So we're actually changing division into multiplication because we can't divide fractions, right? So we have to multiply by fractions. We just went over multiplying fractions in the last video. In the last section. So this should be actually pretty easy. Okay. So we change the division sign into a multiplication sign. And lastly, we have to flip this second fraction. So instead of 1 over 4, it'll actually be 4 over 1. This is how you divide fractions, ladies and gentlemen. This is how you divide fractions. All right. That being said, we go ahead and follow the steps that we just learned in multiplying fractions. Let's go ahead and see if we can cross simplify. We sure can. 4 goes into both 4 and 16, right? So this would be 1. And on this side, 4 goes into 16 a total of 4 times. Let's rewrite our fraction. We have 3 up top, 4 on bottom. Multiply by 1 on top, 1 on bottom. This should be pretty easy. 3 times 1 is 3. 4 times 1 is 4. 3 over 4 is already simplified. A would be your correct answer. 3 over 4. All right. You see how we divide fractions? It's actually we're multiplying by the reciprocal. Okay, a fraction is already kind of a division problem already by itself. 3 over 16 is already, that's already speaking of division in the first place. So you can't divide a dividing problem. Does that make sense? You can't divide a dividing numeric value. Okay, so we have to multiply by the reciprocal. We can multiply fractions, but dividing fractions isn't necessarily true. Okay, we multiply by the reciprocal. All right, let's go ahead and move on to the next question. 9 over 10 divided by 3 over 5. Okay, 9 over 10 divided by 3 over 5. So first, what do? We multiply. So we change that division into multiplication by the reciprocal. Okay, whenever you hear that, just think about flipping this second fraction. We keep the first fraction, we multiply by the reciprocal. So instead of 3 over 5, we would actually put 5/3. Boom. Now, can we cross simplify? We sure can. In many ways, actually. What number goes into both 5 and 10? 5 goes into both 5 and 10. 5 goes into 5 a total of 1 time. 5 goes into 10. 5 times 2 is 10. So this would be 2 on the bottom. What number goes into both 3 and 9? That would be 3 itself. 3 goes into 3 1 time. 3 goes into 9 a total of 3 times, right? 3 times 3 is 9. We go ahead and write our new fractions. 3/2 times 1/1 equals 3 times 1 is 3. Anything times 1 essentially is itself. So 3 times 1 is 3, and then 2 times 1 is 2. If you remember in the earlier section, this is called an improper fraction. Okay, an improper fraction. So let's go ahead and do what we did last time. 2 goes into 3 a total of 1 full time. You can fit 2 into 3 a total of 1 time. And then it has 1 as a remainder, right? How many remainders does it have? 1. Okay. 2 goes into 3 a total of 1 full time with 1 remainder, and the denominator stays the same. See how everything is kind of tying into each other? We turned our improper fraction into a mixed number. Okay, 2 goes into 3, a total of 1 full time. It has 1 remainder, and the denominator stays the same, 1 1/2. B would be your correct answer. Boom, everything is coming together, man. This is what I love about math, right? It's a foreign language at first, but the more that you do it is the more that you see that, everything really does come together when it comes to this math thing. All right, let's go ahead and do this question. It looks kind of intimidating. However, I think with the skill set that we have gained in this video, this should be no problem. So the first fraction stays the same. Keep the first fraction just how it is, 7/30. Now we have to do what? Multiply by the what? Reciprocal, meaning we flip this fraction upside down. So instead of 5/6, we'll have 6/5. Can we do what? Step 2. Can we cross simplify? If we learned anything from our mental warm-up multiplication session, we know that 6 does fit into 30 evenly. So 6 goes into 6 1 time. 6 goes into 30 5 times, right? 5 times 6 is 30. And then obviously we can't cross simplify 7 and 5. So our new fraction would be 7/5 times 1/5 equals 7 times 1 is 7, 5 times 5 is 25. 7/25. And we can't simplify because we already cross simplified, making everything so much easier for us. Boom. Lovely. 7/25. All right, let's go ahead and jump into this next question, because so far so good. Let's take the training wheels off and see if we can do it without the steps written on the screen. All right, let's see if we're learning anything. So 5/24. What are we gonna do? We're gonna keep the first fraction the same. Step 1 is we keep the first fraction the same. Divided by 2/3. So we keep the first fraction, and now we have to multiply by the, if y'all remember the word, go ahead and comment in the comment section down below. Go ahead and comment in the comment section down below. We're gonna multiply by the reciprocal. meaning we flip the second fraction. So instead of 2 over 3, we're going to flip it upside down and put 3 over 2. The next step is we're going to look to see if we can cross simplify this fraction. So it doesn't look like we can cross simplify the 5 and the 2. However, it does look like we can cross simplify the 3 and the 24. Okay, by using the number 3 itself. So 3 goes into 3 a total of 1 time, and 3 goes into 24. What times 3 is 24? Is it not true? 8 times 3 is 24. So then we rewrite this fraction, 5 over 8 multiplied by 1 over 2. 5 times 1 is 5. 8 times 2 is 16. 5 over 16. We can't simplify because it is already simplified. D would be our final answer. 5 over 16. All right, moving on to the next question. Here's a good one. This is an interesting one, I should say. 7 over 16 divided by 7 over 16. Okay. So 7 over 16, we're going to keep the first fraction the same. Now we're going to multiply by the, go ahead and try to comment, spell it correctly in the comment section down below. Reciprocal, right? So instead of 7 over 16, we're going to actually flip this to 16 over 7. Bam. Already your eyes should be kind of noticing certain things, right? That when we cross simplify, everything should actually be very simple. What number goes into both 16 and 16, ladies and gentlemen? 16 goes into both of them, right? So 16 goes into 16 a total of 1 time on both sides, because obviously 16 fits into itself once. Same with 7. What number goes into both 7 and 7, ladies and gentlemen? 7 goes into both of these numbers, right? So 7 fits into itself a total of 1 time, a total of 1 time. Okay. We rewrite our interesting fraction of 1 over 1, aka 1, and we're going to multiply that by 1 over 1, aka 1. 1 times 1 is 1. 1 times 1 is 1. And whenever you have a number itself over itself, it equals 1. All right. So 1 over 1 is equal to 1. 2 over 2 is equal to 1. 8 over 8 is equal to 1. Okay. 1 over 1 is equal to 1. B would be the correct answer. All right, let's do 2 more questions before we go ahead and wrap it up for dividing fractions. 1 over 5 divided by 5 over 7. 1 over 5 divided by 5 over 7. So we keep the first fraction the same. And instead of dividing by, we're going to multiply by the reciprocal. Instead of 5 over 7, we know that it's going to be 7 over 5. It doesn't look like we can do any cross simplifying anything, right? So 1 times 7 equals 7. 5 times 5 equals 25. 7 over 25. D would be the correct answer. All right, so that one is pretty simple. Not bad. That one's even easy. Let's call that one easy. 7 over 25. And let's dive into the last question that we're going to do in today's study session. Yikes. Yikes. All right. 4 plus 2 as the numerator on the left side over 3 plus 5 as the denominator. divided by 7 minus 2 as the numerator over 16. All right. Even this, I think that we're less intimidated by seeing a question like this by now. So let's see how it plays out. 4 plus 2 is 6. Let's go to the denominator. 3 plus 5 is 8. This 16 stays itself. And then on top we have 7 minus 2 equals 5. 16 remains the same. So what do we have? 6 over 8. Honestly, this fraction, as of right now, we can simplify because 2 goes into both of these numbers. So if we divide by 2 and if we divide by 2, it would give us 3 over 4. Okay, so however we want to do it, if we want to go ahead and do 3 over 4, right, on this side, and then we multiply by the reciprocal. So I think I'm getting ahead of myself actually. All right, so instead of this, let me go ahead and just write it as it is so I don't confuse anybody, right? So we drop this division sign down on this side, and then we have the fraction of 5 over 16. Okay, 3 over 4 divided by 5 over 16. Let's go ahead and now begin to solve this question as we know how to do. We're going to keep the first fraction the same, so 3 over 4. We're going to multiply, and we're going to flip this 5 over 16 and make it 16 over 5. We can see that we can cross simplify the 4 and the 16 by using 4 itself. So 4 goes into 4 a total of 1 time. 4 goes into 16 a total of 4 times. Right? So now we have 3 over 1 times 4 over 5. 3 times 4 is 12, and 1 times 5 is 5. Let's see if we can turn this improper fraction into a mixed number. 12 over 5. How many times does 5 go into 12 evenly? 5 can fit into 12 a total of 2 times, because 5 times 2 is 10, right? With a remainder of 2, 11 and 12, right? And then the denominator stays the same, being 5. 2 and 2/5. We change this improper fraction into a mixed number, 2 and 2/5. We go to our answer key. Look at that. A would be the correct answer. 2 and 2/5. All right. So I like to show you guys that way. But then instead of us simplifying this 3/4, right? If we had not simplified that 3/4, let's see while we're at it. All right. So let me see if I can do this real quick. What did we say up top? 4 plus 2 was 6. 3 plus 5 was 8. 7 minus 2 was 5. And then the 16 stays the same. So we had 6 over 8 divided by 5 over 16. 5 over 16. So let's do it like this, right? Instead of simplifying that 6 over 8, for whatever reason, if you found yourself trying to solve this, let's see what we can do. So 6 over 8 stays the same because we keep the first fraction. Now we're going to multiply by the reciprocal, 16 over 5. And look at this. 8 and 16, we can do our cross simplification by using the number 8 itself, right? So 8 goes into 8, a total of 1 time. 8 goes into 16, a total of 2 times. And now we can multiply going across. 6 times 2 would be 12. 1 times 5 would be 5. And here we are in the same spot. So regardless of which way that you chose to go, the answer would have still been the same. So 5 goes into 12 a total of 2 times. 5 times 2 is 10. It has a remainder of 2, and the denominator stays the same. 2 and 2/5. And that, ladies and gentlemen, is how you divide fractions. That's how you divide fractions. So there you have it, guys. That is today's video on how to solve for fractions. How to solve for fraction-based questions. I hope you guys are feeling a lot better at the end of this video than you did going into today's video. If you found value in today's video, go ahead and hit that like button. Comment in the comment section down below that I will pass my next Asvab test. And hit that subscribe button so I can let you know, welcome to the family. Always remember that success is made by actions. So get up, go grind. I'll see you next time.